today's class I'll be explaining about voltage multiplier. So voltage multiplier is a circuit which converts an AC signal into DC. Say if your AC signal is of lower voltage, then you can use a voltage multiplier where your output will be a DC output with higher voltage. So voltage multiplier converts a AC signal into DC signal. So here I have mentioned like multiple DC signal. What is this multiple DC signal? Is that you will get an output voltage double the input voltage, triple, or 4 times. Say if you are using a voltage doubler, you will get an output voltage twice the input voltage. If your output, if you are using quadrupler, then your output will be 3 times. If you are using quadruple, your output will be 4 times. So you will get an output voltage as much or as many times the input voltage. So all you need is an AC source and a power transformer. For the construction of voltage multiplier, you need an AC source and a power transformer for its construction. So it is very much easy to construct. If you see the advantages of voltage multiplier, it is very much easy to build because it mainly requires an AC source and a power transformer along with a capacitor and diode based on the requirement, whether it is a doubler or a tripler or a quadrupler. And the transformer, if you see, it also converts an AC signal to higher voltage DC, but it's very much costly to build. This voltage multiplier is cheap compared to the transformer, which actually does the same operation. So first we will see the voltage doubler. So voltage doubler means I already told like the output voltage should be twice the input voltage. Say if you are applying any AC source, AC signal. So first we will see the positive and the negative of cycle. For positive of cycle, okay, first you will apply a positive cycle. When you apply a positive cycle, this transformer's X will become positive and Y will become negative. And when you apply a positive to the diode D1 anode, this diode will become forward bias. So when you apply for positive cycle, diode 1 will become forward bias because we are applying a positive signal to the anode. So if positive supply is given to anode, the diode become positive, that is forward bias, so it will become a closed switch. So it is becoming a closed switch. And same positive signal you will be applying for the diode 2's cathode. So this diode will become reverse bias and it will become open. So if you are redrawing this circuit, capacitor, so this diode is closed now, capacitor, and this diode is open because of the positive input. So plus minus, and here also it is plus minus. So now let's apply KVL for the circuit. See, we can't apply KVL for this circuit because this circuit is open condition. So we will apply KVL only to this circuit. So what happens when you apply KVL to this circuit is that the capacitor is in plus to minus. So VC, and this side it is output. Sorry, there is no output. Again this side you have input minus to plus. So minus Vin equals to 0. So Vin equals to Vc. Okay. Now let's apply a negative cycle. What happens when you apply a negative cycle? Negative cycle. So this X will become negative and this will become positive. When you apply negative to anode diode D1, the diode D1 will become reverse bias condition. and it is now open. Now this negative cycle again you are applying to diode D2. So diode D2, this is the negative cycle, so this will become forward bias and hence it is a closed switch. See how I am telling like diode is open or closed is because we all know if diode, this is anode and this is cathode, if anode is connected to positive and this cathode is connected to negative, then this is a forward bias condition and diode is closed. If this is the diode and if anode is connected to negative and cathode is connected to positive, this is the reverse bias and hence it acts as an open switch. So this we all know. Based on this only I am telling like whether a diode is forward bias or reverse bias. So based on the given input signal, this diode will turn on or off, or you can call it like forward bias, closed bias, or open, close, however you need. So this is how the diode works when you give a positive and negative cycle. So this I'll redraw it for reverse bias condition. So for a negative cycle, capacitor. Now this is diode D1 is open, diode D2 is closed. So C2, C1. This is minus and this is plus. So now this is the input Vin. Let's assume the current direction in the same way. So Vin is now from plus to minus. So plus Vin, this capacitor is plus to minus and this is also plus to minus. Since this is a single circuit, I'll draw for the entire thing. Now plus Vc1 minus Vc2 because the current is going from minus to plus, so equals to 0. So we calculated like Vc1's voltage. Now we will calculate Vc2's voltage, V in plus Vc1, where V in equals to Vc1 is equal to V in here. So V in plus V in equals to 2V in. Okay. So if you see the voltage across capacitor C2, Vc2 equals to 2V. So the voltage across this capacitor is Vc2, that is 2V. So here we have obtained the voltage doubler by using the Kirchhoff's voltage law. So voltage across this capacitor is 2V. So if you need a voltage, if you're using a voltage doubler, you can connect the voltmeter across this capacitor, and if you see the voltage will be twice the input voltage. Same way if you go for voltage tripler, connect an AC source. Okay. So first I'll apply a positive off cycle. Apply positive off cycle. Positive off cycle. This is plus and this is minus. So capacitor is plus minus. Here plus minus and capacitor is plus minus. When you apply anode to positive cycle to diode D1, D2, D3, what happens is that diode D1 will turn on, diode D2 will turn off. So here this point we will consider as Y and this is X. So this Y point is assumed to be 0. Therefore diode D3 will also turn off. So only this diode is turning on. So if I redraw the circuit, AC source, power transformer, diode is closed, capacitor and diode is closed. Okay, so another capacitor, this diode is open, another capacitor, and this diode is also open. Now apply KVL. So this is the circuit, C1, C2, C3. These two are open circuit, so we can't apply KVL to this circuit. Let's apply only to this circuit. So when you are applying a positive, so this is plus minus. So similarly, minus V in plus Vc equals to 0. The same way like previous one, Vc1 equals to V in. Next, apply negative of cycle. Negative of cycle. Negative of cycle. This will become minus and this will become plus. Okay. So when you apply negative cycle to diode D1 will turn off because negative is applied to cathode, anode. So this will turn off. Here negative cycle is applied to cathode, so this will turn on. And here also negative cycle is applied to anode, so diode 3 is also off. Now I am redrawing the circuit. So capacitor C1 plus minus, negative cycle, so minus plus. This is diode D1 is open, diode D2 is closed, and diode D3 is open. Okay. So now apply a KVL. You can apply KVL because this is a closed circuit, and for the circuit you can't apply because this is in open condition. So now apply KVL. So plus to minus. So V in and capacitor also plus to minus Vc1. This capacitor is from minus to plus. So minus Vc2 equals to 0. So Vc2 equals to V in plus Vc1. So Vc2 equals to Vc1 plus, sorry, V in plus V in, that is 2 V in. This also we found out in a previous circuit itself. Next is the main thing that comes. So now you again apply the next positive of cycle for second positive cycle. What happens is that okay, for second positive of cycle, positive, positive, so this is plus, this is minus. This positive is applied to diode D1, but now this point X is considered as 0. So this diode will turn off. And this positive signal is applied to cathode, so D2 is also off. This positive cycle is applied to diode D3's anode, so D3 is on. Now I am redrawing the circuit. Capacitor open. You don't have to draw if it is open. This is also off, open circuit, and the third one is alone, closed. So C1 plus minus, C2 plus minus, C3 is also plus and minus. So you are applying a positive cycle, so this is also plus minus. Now if you apply a voltage, Kirchhoff's voltage law in this direction, this becomes a entire circuit. So Vc1, sorry, this is capacitor C1, capacitor C2, capacitor C3. So this is input V in. Now if you see, the current flows from negative to positive for V in, so minus V in, capacitor is plus Vc1, Vc3 minus Vc2 equals to 0. Minus V in, Vc1 we know it is V in, we don't know Vc3, and we know Vc2 which is 2V in equals to 0. So Vc3 equals to 2V in. So voltage across this capacitor Vc1 is V in, voltage across this capacitor is 2V in, and voltage across this capacitor is also 2V in. Sorry, this is capacitor C3, this is C2. Okay. So this is voltage tripler, right? So what you will do is you will take the output across the capacitor C1 and C3. So V out for voltage tripler will be voltage across capacitor C1 and voltage across capacitor C3. That is Vc1 is V in and Vc2 is 2V in. So you will get 3V in. So that's how you get an voltage tripler, which is thrice the input voltage. Next is voltage quadruple. It is same for these three. It is like previous one. So voltage across capacitor C1 is V in, voltage across capacitor C2 is 2V in, and voltage across capacitor C3 is also 2V in. Similar way, apply a positive cycle, so this will become plus plus. So this will turn on, this is off, this point is considered 0, so this is also off, and positive is applied to cathode, so this is also off. So for first positive off cycle, only this diode D1 is on, so I will redraw the circuit. Plus minus capacitor C1, diode is D1 is closed. Rest all you don't have to draw because diode D2, D3, D4 is on, so that's not required. So for first positive off cycle, this is plus, this is minus V in, and this is Vc. So applying KVL, minus V in plus Vc equals to 0. So Vc1 equals to V in. For negative cycle, for first positive cycle, this is first positive, this is first negative, this is first negative cycle. So what happens when you apply first negative cycle is that negative cycle, so this will become minus plus. So negative is applied to anode, this will become off. Negative is applied to cathode, this will turn on. Negative applied to anode, so off. Negative applied to cathode, this has to turn on, but this point is considered as 0, so this will also turn off. So now I will redraw the circuit. Capacitor, this is open. Now this capacitor, this is closed. This you don't have to draw because it is open. So this you don't have to consider, just consider this alone, C1, C2, and this side Okay. So for first negative of cycle, you will apply negative cycle. So this will become minus and this will become plus. So applying KVL across this circuit, plus to minus, so plus V in plus Vc1 minus Vc2 equals to 0. So Vc2 equals to 2 in. Now applying a third positive, second positive cycle. For second positive cycle again for second positive cycle, this has to turn on, but this will assume it as 0. So this will turn off. Positive is applied to anode, so on. Positive is applied to cathode, so this is turning off. So if you redraw the circuit, capacitor C1 positive, negative. This is open, right? That is off. So you don't have to draw. Next is capacitor C2, that is also off. You don't have to draw. Then capacitor C3, then this third one alone on. So C3, C2, plus minus, plus minus, plus minus. So applying KVL, this is you're applying positive, so plus minus. So minus to plus minus V in plus Vc1 plus Vc3 minus Vc2 equals to 0. So minus V in plus V in plus 2V in minus Vc3 equals to 0. So Vc3 equals to 2V in. These three we have calculated in previous circuits itself. For this we will newly calculate for the second negative cycle. Second negative cycle. So negative cycle, negative you are applying here, this will turn off. Negative applying to cathode, this has to turn on, but you will assume this is 0. So this will turn off. Negative applied to anode, so off. Negative applied to cathode, so this is turning on. So if we draw the circuit, only last one is on. So capacitor, this is not working. So this side capacitor, so this side capacitor, only last one is on. Capacitor and last diode is on. So I will close it. C1 plus minus, C3 plus minus, C2 plus minus, C4 plus minus, and this is negative cycle, right? So this is minus this. Now apply a KVL to the entire circuit. So plus V in plus Vc1 plus Vc3 minus Vc4 minus Vc2 equals to 0. So V in plus V in plus 2V in minus Vc4 minus 2V in equals to 0. So Vc4 equals to 2V in. So voltage across capacitors also 2V in. So for quadrupler, you need an output equal to 4 times the input. Therefore, take an output across voltage across C2 and voltage across C4. So 2V in plus 2V in equals to 4V in. So that's how you calculate an voltage across capacitor to find the required voltage, to get the required voltage. So for voltage doubler, you will take a voltage across Vc1. Sorry, take a voltage across Vc2, this one. For voltage triplet, you will take a voltage across VC1 and this capacitor, C3 capacitor. For voltage quadruplet, you will take voltage across C2 and C4. So that's how voltage multiplier works. That's a very easy topic, but I don't know how I explained it. If you have any doubts, please let me know, or if you have any suggestions, also please let me know. Thank you.